Hello everyone, and today we shall work with RStudio on the topic of preferred car engine analysis that are there in the market. So if you are not very used to RStudio, you do not know how to use it, I suggest you watch a video on how to use this RStudio and then get back to this video. So without much further ado, let us start with this program. Okay, so first we have to install a set of packages like ggplot2, macwriter, grid extra, plyr, dplyr, and reader. Since I've already installed these packages, I shall just call them one by one. So now let me first call ggplot2. So what exactly is this ggplot2 function? We could just say, why it sounds more like plotting, but why don't we just use a function plotting? So ggplot2 gives a lot of more aesthetics, and it also gives a lot of visual understanding to the plot and more design. Okay, so the next one is macwriter. Macwriter is, it provides like a mechanism for chaining commands with a new forward pipe operator. Like the operator would be like percentage greater than percentage. So this operator, will forward a value or an expression, the result of an expression into the next function, call or an expression. Okay. So the next function, the next package that we would be installing is grid. So what does grid do? It basically, it rewrites the graphic layout and capabilities, and also add some support and interaction with the data set that we are going to use. Okay, so grid extra is also one more package that gives a little more extra capabilities and usabilities. ply, on the other hand, plyr, it makes it simple to split the data apart. If you want to use it into like training data set, test data set, it makes it more easier to use that type of stuff into which you want. So this package is it comes very much handy. dplyr, it's also the same way, but it gives more manipulation and more abilities for manipulating the data more than plyr. So we use that package also. And finally, we use the package as reader. So here readdr is to provide a fast and friendly way to read the rectangular data. So by that, what I mean is like csv or tsv and fwf formatted data sets. Okay, so it's designed to flexibly pass any types of data found in the wild, while still cleanly failing when data unexpectedly changes. Okay, so now here in this next step, we shall import the data with the function of read.csv. Okay, so here this is the data on which we would be doing analysis on. So here, as you can see, this data is quite a big. It has about 14 columns and 428. It has about 15 total columns with 428 entries that are entered into this data set. Okay, so as we just want to see, like, get a basic overview of this data set, we can see here down that this gives the head function gives the first 6 values of each variable that is there present. Okay, now we want to get a summary of this data to see what exactly it is, like the length, the first quartile, the median, means, maximum output, maximum variables, maximum values. Okay, so now in order to use this data, we have to first pre-process the data. So because it can either cause a lot of disruption into the analysis or any anything that we are doing with this data. So the first thing, we would find the strings. So what are they? Basically, they're integers, numerics, or characters or anything like that. So we shall find out to get a better understanding. Then we would use this function complete case, to remove some unexpected values or like null values that are there into this data set, so it won't cause any hindrance to further when we do analysis or any research upon it. Okay, so here these are some of the functions, and if we want to say the table of the car cylinder, it will show you which type of car cylinders, like we say V6, V4, V8 and all. So this table right here, it shows you the number of values for each. So like V4 has about 136, so 136 cars contain the V4 engine, whereas 190 contain the V6 engine. Okay, so now let's move on to the main part, that is the plotting. So here we would use qplot, which is the quick plot. It just uses like the data that xlab is where we would name the x axis, and y is the ylab is the where we would label the y axis. Main is the name of the plotting that we want to give it, that is histogram of number of cylinders. So let us run it, and as you can see on the plotting section over here, that we can see that the number of cylinders that was most seen were the V6 engines. Okay, so the more V6 engine type of cars were produced. Now as we move on to this next one, where it would show you which type of cars companies most produced. So many companies, they would prefer making sedans over hybrids, or then which was followed by SUVs and then sports. Okay, so the next one would be which country the cars were most produced, so the origin of these countries which the cars were most produced. So here you will see Asia was topping in the production of cars, with USA following behind. Okay, so the next one would be where this is the function of ggplot that we use. So this function ggplot, here it shows which brand mostly use how many cylinders in their car. See, so ggplot makes it more attractive, and it also has like a more visual aesthetic towards it, so it gives you more color radiant for better more understanding and all. So as you can see that as you can see over here, that V6, so V6 were chosen by maximum of the companies of the car. So V6 were made by most of the companies, as you can see in this picture. Okay, so now let's move on to the next one, in which we shall find out which type of cars consisted of how many cylinders. So as you can see here, it is given that the pink is the hybrid, and olive green is sedan, green is sports, blue is SUV, and so on. So most of the V6 engines were mostly consisted by the sedan section, and which were mostly there, and the pink section were the wagons, which more or less consist of the V6, but very less they consisted of the V8. So very less companies made V8 engines with wagons. Okay, so now moving on to the next one, which is which car had what type of drivetrain. So as you can see, front wheel drive was chosen by most of the cars, that is sedan. So as most sedans would only choose like front wheel drive, is more economical and less confusing in making, and doesn't take much time, whereas most four wheel drive was taken by SUVs, as they would use more off terrain and four wheel drive, whereas rear wheel drive was mostly chosen by sports cars like Lamborghini or Ferrari, where they would use various technologies such as drift analysis or various other stuff that they use in their day-to-day production of their cars. Okay, so now here we can see this ggplot function. Okay, I forgot to mention that AES in these ggplot function that we will be using stands for aesthetics. So here that AES function is an aesthetic function, and here geom is one function where we would use multiple like sub functions beyond that. So like if you would use geom point, geom would be like it would give a plotting data set, data visual. Geom bar would give a bar chart and others. So geom smooth is another function in which we label the method. So here in this function we label the method as linear modeling LM, so where we use linear regression and we find out what is the effect of the weight on the miles per gallon in the city of each car. So we can see here that based upon this diagram that is given as an output, we can see here that more heavier the cars, the lesser the miles per gallon the MPG it gives because of its weight. So in this function we can also see the effect of the engine size on the MPG in the city. So from this we get to know that the MPG in the city is mostly in between 20 and 40 when the engine liters is of 2 liters to 4 liters. So the mileage is mostly from about 20 miles per gallon to about 40 miles per gallon. That is when the engine size is between 2 liters to 4 liters. Okay. Now to import another set of data, that is the car sales. So this is, I import this data. From here I shall also remove any null values, that is pre-processing the data. So this is the command which I would be using for pre-processing my data. So here one function that you might see is AVE, which stands for like average, group average. It's the group average on over level combinations of the factors that are there here. Okay, so now we shall individually process each of these variables. So processing each of these variables individually, and now we shall encode the categorical data. So by this we we create a factor for this for the variable of vehicle type with levels as passenger and car. So here in these labels we will label them as 1 and 2. So we run this program. Okay, now we split our data into training and testing sets. So here we use the function setC to 123. We also split these. Now we use a function as CA tool. So what does CA tools do? It contains several basic utility functions including moving, rolling, running, and it also windows statistic functions. Okay, so this data we use it to split. We use and split ratio we turn it to 0.8. so we use this function and to sample dot split, where we split the data into two sets. That is, one is here is the training set which uses a function as subset, and test set. So now we fit the regression model to the training set. So we use this regression model as a training set. We use a training set on this model. So using the LM function where the formula is sales in thousands against all. So here we use the data as training set. So here we have, now we shall print a summary of this regressor vector that we have created here. Okay, so as you can see over here that it gets the function of sales in thousands along with the other variables. So here we would find the first quartile would be negative 26.1 with all the other variables, and medium would be minus 4.3. So here we could see the estimates, the standard errors, and the t value that is given over there. Okay, so where we could see also here we would see the multiple r squared as 0.4247 and adjusted r square value also that is given here. Okay, so from here from this we can see the wheelbase is highly statistically significant on dependent variables over here. So now let's run the remaining code. The remaining code would be here, that is why predict. We use the predict function to predict the aggressor variable that we have created with the data using the test set that we have created over here. Okay, so now we use this test set here. So these are the test set variables that are given, and then we use the y predict. So this in turns predicts the main objects that we want. So thank you for listening, and this was the video on analysis of preferred car engines. Thank you.